Welcome to West Virginia, or not West Virginia, but I'm enjoying traveling around. If nothing else, I'm getting to see a lot of territory, or not. Okay, well, let's see joke of the day, because I know you love joke of the day. So why didn't the dog want to play football? Why didn't the dog want to play football? I mean, football's a great sport. Why didn't the dog want to play football? Because he was a boxer. A boxer dog, not. Anyways, I love these joke of the day. I bet you are too. So let's take a look now at the quotient rule of logarithms. We've looked at the product rule of logarithms. It said if we had one logarithm, one base, and we had a product that we were taking the log of, we could split that product up, the factors up, and we could take the log of this factor, we could take the log of this factor, and we'll put the two individual logarithms together through addition. With the quotient rule works similarly, but let's and hopefully there's an easy way to memorize this. The quotient rule says similarly, b, m, and n. Now they're going to be positive real numbers, not just any old real number, but positive real numbers. And the b is not going to be a 1. So what happens here is similarly one log, but we're dividing these factors, dividing them, not multiplying them. Now, if multiplying them resulted in addition, division being the opposite of multiplication, what would be the opposite of addition? Yeah, subtraction. So similar idea that we can take the log of each individual factor, logarithm of the top, and then logarithm of the bottom, and we're going to subtract the two. Another way that this is easy to memorize is because it likens to those laws of exponents that we've looked at before. Remember the laws of exponents said when we are dividing the bases and the bases are the same, then we're going to subtract those exponents. Notice, remember with those laws of exponents, we said we're going to subtract top minus bottom, m minus n. Same thing here. When you do the subtraction, you do the log of the top minus log of the bottom. And again, notice that that breaks up into same base. So it works very similar to that product rule, but now it just deals with quotients. And like I said before, product rule had these two multiplied together, and division is the opposite of multiplication. Product rule had addition here. Subtraction is the opposite of addition. So they all kind of go hand in hand, making that memorization much, much easier to follow through with. As well with the product rule of logarithms, I said that the product rule of logarithms applied to common logs, which is base 10. They applied to natural logs, which is base E, shortcut written as lowercase cursive ln. Same thing here with the quotient rule. It applies to all logarithms, even your common logs and your natural logs. So let's take a look at using this. We're going to take a look at two examples where we expand each logarithmic expression as much as possible. So notice here that I've got the log base 9 of this division problem, this quotient. So according to our quotient rule, we can take this and we can split it up and we can do the log of the top, log of the bottom, separate them by subtraction. So when we do log of the top, we're going to get log base 9 of 9. And then we're going to get log base 9 of x, and we're going to separate the two by subtraction. Now recall before, if we could simplify, or in other words, evaluate the log, we certainly want to do that. Notice in this one, that means base to some power outside is going to equal that number on the inside, and that's going to result in 9 to some power is going to give us a 9. Well, 9 to what power will give us a 9? That would be a 1. 9 to the first power equals 9. So this right here simplifies or can be evaluated as just a 1, and I have 1 minus log base 9 of x. Now I cannot do anything with this log base 9 of x because that would indicate 9 here base to some outside power is going to equal that number on the inside. I don't know 9 times itself, how many times would give me an x? I can't figure that out. That's not possible. So therefore, this is as simple as this one will get because we are able to evaluate this, but we did expand our logarithm. And expanding the logarithm is kind of weird thought, but expanding the logarithm actually helped us to simplify it because we were able to evaluate this part right here. Now let's take a look at another example. Log base 4 of 64 over y. Now, I've got one logarithm and a quotient here, and our quotient rule for logarithms says we can split that up. So what we can do this time is we can say, okay, I'm going to take log base 4 of the top, I'm going to take log base 4 of the bottom, and I'm going to subtract the 2. And once again, if I can evaluate any part of that, I'm going to evaluate it. Notice here, this would indicate 4 to some outside power here. 4 to some power will give me that number on the inside, will give me a 64. That tells me I want to multiply 4 by itself. How many times to create a 64? Well, let's see if we can figure that out. 4 times 4 is 16. 16 times 4 is 64. So that means this exponent here is going to be a 3. So therefore, this can be evaluated or simplified as just a 3. So now I have 3 minus log base 4 of y. And on this one, remember what that will indicate is 4 to some outside power. 4 to some outside power, I don't know what it is going to equal the number on the inside. I cannot take 4 and multiply it by itself any number of times to create a y. That's not going to happen. So this cannot be evaluated, this part right here. It cannot be simplified, and this is as good as that one's going to get. So once again, expanding the logarithm actually helped us to simplify it because we could evaluate a part of it. Now, like before with the product rule of logarithms, we said it helps us to expand, but it also helps us to condense. Same thing here with the quotient rule. What we did was expand it because we took a simple or a concise, not simple, but a concise logarithm, expanded it out and said, okay, I can take the log of the top and I can take the log of the bottom, and I'm going to separate them by subtraction, keeping that same base. That was expanding it because it makes it longer, a larger mathematical sentence. So we can condense it. We can say, okay, what if we start off with an expanded? Very important to notice we have same base. If you do not have the same base, you cannot condense these. But when you do have the same base, you can condense it into one logarithm with that one single base. You can take what's in front, put it on the numerator, take what's in back, put it on the denominator, and create a fraction, or in other words, a division problem. So expanding creates a much lengthier mathematical sentence. Condensing it shrinks it into a shorter mathematical sentence. And it's all about being able to simplify that logarithm. So let's play now with condensing. So in the 2 examples that I have here, we're going to condense each of the logarithmic expressions. We're going to write the expression as a single logarithm whose coefficient is 1. So notice in this one, very important to recognize first, do I have same base? Yes, I do. When I recognize that I have same base, then what I can do is I can condense it into one single logarithm. This is subtraction, so I'm going to put this factor in the numerator. I'm going to put this factor in the denominator. Now, can I take a 405 and divide it by 5? I sure can. And when I do, 405 divided by 5 is going to be an 81. Oh, that should not be equals. I'm terribly sorry. Excuse me. Should be an 81. Can I evaluate this logarithm? Well, if I could, then what would happen is I would say base to some outside power, I don't know what it is, will equal the number on the inside, will equal an 81. So how many times would I have to multiply 3 by itself to create an 81? Well, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that means this exponent here is going to be a 4. So therefore, yes, I can evaluate this, and when I do, I'm simply going to get a 4. And so by condensing it, once again, we were able to evaluate the logarithm. So now let's take a look at this one. What's going to happen here is, yet again, I'm going to say, okay, I have same base. Remember, when it doesn't look like the base is there, what is the understood base? Yes, a 10. But I do have same base. It is subtraction that likens or leads to division. So I'm going to keep the base, condense it into one single logarithm, logarithm. And remember, when it's a base of 10, I don't have to show that. And now the number in front, or this is an expression, but that expression will go on the numerator, and this factor will go on the denominator. Now, can I do that division? Here I was able to do the division. Can I do the division here? Be very careful. The x's could cancel if this x will as well divide into the 7. This denominator has to divide into every term in the numerator in order to make that division happen. And it won't divide into every term in the numerator. So therefore, I cannot simplify this rational expression here. I cannot simplify that fraction. I am stuck. There is no more that I can do this. and I cannot evaluate it like I evaluated this or right here. I cannot evaluate it because being that the base is 10, that would indicate 10 to some kind of power is going to equal this, and I have no idea. I can't take 10 and multiply it by itself a certain number of times in order to create that. That's not going to happen. So this is as good as it gets. So hopefully you're seeing that the quotient rule for logarithms, very much like that product rule for logarithms. They are just basically opposites of each other because division is the opposite of multiplication, subtraction is the opposite of addition. And kind of easy to memorize because it goes back to those laws of exponents that said when I divided, that led to subtraction. When I divide, it leads to subtraction. I hope that helps. Have a great day.